Hey guys, welcome back to Mat++. In this video, we're going to be going over header files and most importantly, classes. If you've not already watched my videos on functions and more advanced functions, check those out first in order to fully understand how functions and classes relate to one another. So starting out, we have to know how to create a header file. To do so, if you are in Visual Studio, look to your right at the Solution Explorer, find where it says header file, right click, go to Add, New Item, it'll pop up, and then as you can see, it'll have Visual C++ already selected, and then you'll have your C++ file, which is a .cpp, and then your .h, which is a header file. So you can go ahead and name this whatever you want. You can leave it as header h for this example. Go ahead and add it. So Visual Studio is automatically going to add #progma once. Go ahead and just leave that, and then just go back to your main CPP file. Okay, so now that we have this header file, what do we actually do? And what is a header file used for? Well, a header file is used for storing data, like classes and functions, and basically acts as an extension of our main file. And this allows us to use the code in a header file in multiple files. We don't have to copy and paste, we don't have to reprogram it. We can just keep it in a header file and kind of keep it there until we need it, no matter what we're using it for. And this is especially good if you're working on multiple projects and you have a function that works really, really well. You don't have to worry about copying and pasting it. You just have to include this file in whatever project you're working on. We can't just add the file though and it work automatically. We have to actually include it with our main CPP file. So let's see how we do that. It's very simple. You're going to include it just like you would a library. So include, and then instead of angle brackets, we're going to use double quotes. And then as you can see, Visual Studio automatically knows that I'm wanting to add a header file because this is how you add a header file. So if I go down to header H and just hit enter, it's going to add it for me automatically. And then this is the header file we just added. There we go. And then these, as we know, are libraries. But what is different between a header file, like the ones that we're adding, and a library, like IOStream? Well, libraries contain the actual executable code, while a header file contains the information needed to make the code work. Meaning, it tells the code how to be called, and a library contains the code to actually implement the functionality that we're wanting. Once this is added, we're going to want to include all of our libraries into our header file. Now, this isn't necessarily a good practice. You're only going to want to include the libraries that you're going to be using in this header file specifically. So if we didn't use string in this header file, we would not want to include string. If we were to use string in another header file, we would then include string in that header file. We only want to include the libraries that we're using and nothing else. And the reason for that is this cuts down on waste, and the more libraries we have, the slower our program is going to be. So if you think of it like if you have IOStream, the IOStream library right here, this contains 3,000 lines of code to make cout, endl, and all of the other keywords actually work. 3,000 lines. So if you have a 500-line program, you can imagine that each library you have, you're basically copying those lines, so all 3,000 lines, and pasting it on top of your program. So your 500-line program becomes 3,500 lines. And then for every library after that, you just keep adding more and more lines of code. So even if a library is 1,000 lines and you have 5 of them, that's 5,000 lines of code that you don't necessarily need. And it's just going to exponentially decrease the speed of your program and just make it run way too hard. Now, we're not going to get into optimization. This is a very high-level look at it. But if you are a computer science student, or if you're going to be taking a computer science course, you're definitely going to go over optimization. Your professors are really going to be upset if you start including extraneous libraries for absolutely no reason. And if you take an algorithms course, you're actually going to find out the very nitty-gritty details of why you can't do this and what happens when you do. So I won't bore you with that information. It is related to programming, but here we don't really need to know everything that's going on behind the scenes, except not to do it unless we absolutely have to. But if anyone has questions about header files in the description or optimization, let me know. That's all we're going to get into in this video as far as header files and optimization is concerned. So now we're just going to move on to classes. Firstly, what are classes? Classes are just a way of taking related data and information and putting it into one unit of sorts. Not that unit is a technical term, but it's the best way to describe what a class is. With this class, we can have multiple functions that relate to one another and organize them in one structured box. If you remember the issues with global variables in the last video, we need to make sure we know which functions are accessing what data. And this is solved with classes. To define a class, we need to go into our header file, up here, and then just do class, and then give the name of your class. In this case, it's going to be my class. Enter in curly brackets, and remember, this semicolon is here for a reason. In functions, you don't want this because you get an error, but in classes, you absolutely have to have a semicolon or it won't run, it won't compile. If you guys know, my favorite way of typing variable names would be lowercase in the front and then capitalized in the back, so my function would look like this. For classes, you'll notice that I have a capital M and a capital C. This is just because classes, by standard, are capitalized. The first letter is always capitalized, and then you just continue like normal. This is just a way to quickly see what you're looking at is definitely a class. You see that my class, even without the word class, you know that's a class. Okay, I've said the word class way too many times. So inside of this class, we can start declaring variables. In the case of classes, these are now called members. So a variable, let's say it is int x, and we'll set that equal to 0. It is a member. So everything inside the class is a member of the class. If we have a function, it's a member function. If we have a variable, it's a member variable. With classes, we also need to specify the permissions for each variable and function. We can have a public, which lets anything inside or outside the class access and modify the variable or see what's inside of the function. We can have a private, which only lets the class or the member variables and member functions access private variables. Anything outside the class cannot see it. It will actually give you an inaccessible error. You cannot write to them and you can't read them. You can use what is called a setter and a getter to write to it from outside the class. We will get into that in a later video because that's more in depth about classes. We're just going to do like a very high level structure of classes in this video. But if that's something you're interested in, just see the next video in this series. At any rate, private variables stops functions from accidentally or unknowingly overwriting the data. If you remember the global variable issue that I'm always talking about, this stops that. This is what stops variables from accidentally getting overwritten. It's because they can't get overwritten accidentally. You have to specifically tell it to overwrite something, not just, oh, I thought it was overwriting X, but I was actually overwriting Y. That can't happen. It's not that easy anymore. You can also have a protected permission, which works more for child classes, which child classes are just about inheritance of the class. You can declare all of these member variables and then give that to another class to use, and that's called an inheritance. You can inherit publicly, which gives you access to all of the public variables. You can inherit privately, which gives you access to all of the public and protected variables. And that is why you would use protected, because it keeps it like private. It's the same security as private, but if you want to have a child class that has inheritance from the parent class, you can still access those, and those automatically become private. And to do so, you would just go above our int and type in the word public, and then a colon. And then anything below this, so make sure that this is indented in. Anything below public is going to be public until you change the type. So if we wanted to do protected, we can do protected, if I could spell it. There we go. We can do protected, and let's say int y is protected. We don't want anyone to see int y, it's super secret. And then we can have private. You don't have to have these indented like I'm doing. It just, I think it looks a little cleaner and it helps keep the code a little structured. And then we can have another int, and we'll call that z. And it's actually going to be equal to 100. It's really big. It's really important, so we're really going to protect it. So now that we have our variables set, we have our public, protected, and private, we can actually do the same thing with functions. So if we want to have a public function, we can just call void, and then my function. We can declare it here. So now it's public, 100% public. Then we can have a protected one. My protected func. And then we could even have a private one, which is just the same as what we're doing before. No need to actually show it. So if we want to define our functions, how do we do so? Is it as simple as just doing void my function and then defining it here? You might think yes. However, watch what happens if we try to access something like x. So we'll do cout. You are in my function inside of class, my class. All right, so now we know exactly where we're at in the program. But now, if we try to access something like x, so if we do a cout x, what happens? There's a red line, which, as we know, that means something's going on, and it's because x is undefined. Remember scope. The scope of a variable or an object or anything is between the brackets. We learned this in the last video. So x only exists inside of my class. So my function, because it's a member of the class, should be able to see it, correct? Well, we have to use the scope resolution operator, which is the 2 colons, in order to actually tell it what scope it has. Void my function has no idea where it's at. It just knows it's being declared. It just knows it's being defined. And it happens to know that it's public. So how do we actually tell it that we want its scope to be the class? It's very simple. We leave void in the front because we want it to know that it's void. And then we type in my class, exactly how we have it up top, and then 2 colons. That's the scope resolution operator that's saying, hey, this is a void function. Specifically, it's the function in my class. It's the my function inside of my class. Because we can have multiple functions called my function with different scopes. We don't want that in this case, so we want to tell my function that it's part of my class. And here, if we look up here, it's just saying that there is no definition found because we didn't actually define it down here. You would just do the same thing as you did here. You would just declare it using void space my class : my protected func, and then give it whatever definition you want. Protected and private functions are great if you're accessing private variables. It just makes them more secure because you can't just access everything without special permissions using a setter or getter. And this way, if you have specifically a private function, you can limit that from getting inherited to a child class. So now that we have our function defined, my class created, how do we actually start to use this? Well, why don't we go to our main CPP file and we find this empty space here. So what do we need to start typing? First, we need to remember that C++ is an object-oriented language, which means we probably need to create an object to access this class. And to do so, you just type in the name of your class and then give it a name. You're declaring an object here, so give the object a name that you'll remember. It can be something as simple as C. So anytime you see a C, you know that you're accessing your class. You might want to call it my class in lowercase. That's usually the standard, so if you see my class capitalized and you'll see my class lowercase, then you know that my class is an object. And if you hover over here, it's showing that it's a local variable because it's in main. But now we can actually use this to access our function. So just to show you, if we go back, we have our my function in the header file. And if we try to type in my function exactly how we have it labeled, it's not going to work because my function does not exist. It's undefined. So to give it its scope, we would do my class dot my function. Now it knows that the function that we're actually wanting to use is from my class. So if we go ahead and hit compile and run, there are build errors. Why? Well, it's because we forgot this. Our using namespace standard. So if using namespace standard is here and not here, we cannot access any of our couts by just doing cout. What we need to do is type in using namespace standard. Then we can actually comment this out, so we don't need it, and we don't want it in both files because we don't want it to keep defining itself every time it gets included. So let's do another run, and it should run no problem. So hello, you are in my function inside of class my class, and it displays 0. So if we wanted to display something like z, let's try to do that. So let's do cout. Here is z. Now remember, z is private, so will z work? Well, we'll find out. We hit run, and bam, it does work because remember, the function, because it's a member of the class, is allowed to. It has the proper permissions to actually access. So although my function, which is a member of my class, can access z, what happens if we create another function called void myfunc2, give it its parentheses, and let's start to define it in line? What's going to happen if we do cout? Hello, you are in my func2. We end it, and then we say here is x space. We'll give it x. We say cout. Here is z, and then let's give it z. Oops. I cannot type today. Alright. So we know that x and z are not defined. They're undefined because they're not in the proper scope. So because we need to give it an object, let's go ahead and do that. So let's do my class, and then my class. Let's do my class.x, and let's do my class.z. Okay, we have a red squiggly line. Why is that? Well, we know that it's private, and if you look at the member, it says it is inaccessible. So if we try to run it, we're going to get an error because it's inaccessible. We cannot have z because it's private. This is not a setter, this is not a getter, this is just a random function. It's not allowed to access private variable. So if we run it again, it's going to run no problem. We don't have the cout, but we can run it by just calling. First we need to throw this up here so we don't get any errors. We can just run it from here. And there. Whoops. My fault, guys. Now let's try this. There we go. So as you can see, it says, hello, you're in my func2. Here's x. You can see x, no problem. X is public. X doesn't care who can see it and who cannot see it. Z is a little shy, so it's going to stay hidden. In fact, we're going to get errors no matter what. So if we come back to our main file, can we still run this function from our main file? We had problems with my function not running, so how do we get my func2 to run? Actually, we can just type it in like normal. So if we run this, it'll run twice because we have it being called from my function, and it's going to run again after it comes out of my function. So as you can see, header files, even if you don't use classes, are great because you can keep all of this, at least this, all of this mess in here with all of your includes, and then keep your main file pretty much empty other than just calling the different functions. Alright, that's going to do it for this video, guys. In the next video, we're going to be going over how to actually use this class for more of an advanced purpose, not just defining it and just throwing some variables in there. We're still working towards getting a text-based game going. Once we get classes down, this is going to be really easy and really great. If you want to know what setters and getters are, that's going to be the video for you. So until then, please comment, rate, and subscribe. If you have any questions at all, as always, please leave them in the comments below. If you have any homework problems or questions, please let me know. I would love to help. So thanks, guys. Share this with your friends. And if there's anything else you would like to see in a future video, please let me know. Peace.